Hello students, am I live? Am I audible? Let me know in the chat box. Hi Bacha. Welcome back to this session. Today we are preparing for the JEE Advanced. Let me know if you can see me and hear me clearly. We are live. I can definitely see that. 1 second. Yes, now I can see you guys as well. Good evening. Let me just mute this. Okay, 1 second. Where's the mute option? Hear me clearly. We are live. I can definitely see that. Yes, now I can see you guys. 1 second. Good evening. Let me just mute this. Okay, 1 second. Yeah. Okay, we are live, bacha, we are live. Finally, everything is set. ठीक है. Ma'am, you have doubts in organic chemistry. So I've always told you if you have doubts in organic chemistry, I have told you I have my personal Telegram channel, which is called Nandini JEE, right? Where students send me their personal doubts of organic chemistry, whatever question you have, whether for advanced, whether for BitSat, whether for any other exam that you're preparing for, you can send me directly on this channel. You can send me the screenshots, question, I will answer that. I know there is a lot of chit chat going on right now, but I'm going to stop this so that only questions and answers can be there. Okay, you can join this channel. Okay, once again, welcome back to the JEE Advanced section. Let me go back to this slide. Today we are going to complete the organic part, which was not there in your JEE mains, but will definitely be there in your JEE Advanced section. So if you're someone preparing for the JEE Advanced, very important section. For example, topics like polymer as well as chemistry in everyday life. You cannot hear me? I think you can hear me. Can you hear me? Let me know. Let me know if you can hear me. Can you hear me? Yes, you can hear. Chalo, theek hai. So right now, okay, bacha. Like polymers, yes. Polymers as well as your chemistry in everyday life, these chapters are something which students never do. I know you want to skip on these chapters even if they were in your JEE mains exam, or they are not because they're super tiresome. There's so many molecules to keep to remember, but I'm going to teach you the best way how you can remember those molecular structures as well as how to differentiate between the kind of polymers. It's a very easy, very sweet chapter. Within 1 hour, we're going to complete both of these units. Are you with me? Before that, I have a news for you. As you know that Vedantu is conducting its own Vidya Utsav. It's on 1st May at 12 p.m. You should definitely be a part of it because there are going to be many exciting surprises and many fun activities. You're going to have fun with the best master teachers that you've been following all year around. It's time to unwind, relax, and also to ask your JEE questions, your engineering questions, your school-based questions, whatever questions you have. If you're preparing for JEE 2025, again, meet your favorite master teachers at this event and grill them with your questions, right? ठीक है बच्चा, चलो, I'm audible, perfect. And also once again, with the bottom of my heart, I want you guys to purchase this book if you are preparing for JEE Advanced, because I, from my own eyes, have seen so many questions repeating from this book. This book is extremely good if you're preparing for JEE Advanced. So along with the theory, go through the questions in this book, because this book also has all the PYQs ever asked for your JEE Advanced section. This is called the JEE Accelerator book. The link to get this book will be in the description box below. You can just click on that and buy the book from the Vedantu Center. Extremely good book. You will see so many questions actually repeating from this book, right? ठीक है? Beta, we're going to prepare for the BITSET exam. Do not worry. If you have any questions, you know where to reach to me on the Telegram channel, because that's where we can connect and have a conversation with each other. Perfect. Let's move on to the polymers section. Are you excited? How many guys? ठीक है बच्चा, चलो. Polymers. So बच्चा, for example, I've only included the things that you should know. ठीक है, only in the very small, crisp format, what you need to know about a polymer. So bacha, polymer are high molecular weight compounds. They have a high molecular weight, but they're formed of very smaller units, which are called what? Monomers. ठीक है? So that's the definition of a polymer. The small units which they are consisted of is called a monomer. ठीक है? Next is what is polymerization. Then bacha, it is the process. ठीक है? Polymer is the big unit. Monomer is the small unit with which that big unit is made up of. Understood? Polymerization is the process through which a monomer like ethene gets converted into a polymer like polythene. Simple. So these are the three terms that you should know. Let's move on to the next thing. Next is classification of polymers. Again, very important on the basis of questions, because very theory-based questions are asked in a JEE Advanced. For example, they're classified on the basis of source. Okay? On the basis of source, they can be either natural, synthetic, or semi-synthetic. Meaning what? Natural, which is found in nature with plants, from animals, right? What are the examples? For example, the protein found in your body is a natural polymer. Okay? And they're also known as biopolymers. Understood? Understood, bacha? Yes. Next is, bacha, proteins are what? What is a monomer in protein? It is amino acid. Similarly, polysaccharide. What are polysaccharides? The carbohydrates that you study. Again, a polymer. They are polymers of monosaccharides. Okay? You read about it in your chapter biomolecules. Then it is your rubber. Rubber, once again, is your polymer of isoprene. Okay? And then your silk, wool, starch, cellulose, enzymes, natural rubber, hemoglobin. Hemoglobin in your blood is also a polymer. Understood? All of these are polymers which are naturally occurring. Next is synthetic polymers. What are synthetic polymers? For example, these are also the artificial polymers. Examples are polythene. Then it is your nylon, out of which your clothes are made up of, right? Normally. Then your PVC. Again, PVC is what? The coating that you get on the utensils, right? For example, the non-stick coating on which your mother cooks food, that is PVC. Then bakelite, then dacron. Dacron is once again an example of a fibrous polymer out of which clothes are made up of. Okay? We're going to study the examples in detail. We're going to study what monomers are used, what actually is dacron. Right now, just keep these things in mind. Ki, okay, ma'am, first of all, the polymers are classified on the basis of the source. Either they're natural, they're synthetic, and semi-synthetic means what? Semi-synthetic means natural polymers, we have modified them in laboratories. We took the natural polymer and we modified them in laboratories. Okay? Example is nitrocellulose. Cellulose which is found in plants. We added the nitro group to it and made the nitrocellulose, and also cellulose acetate, cellulose xanthate. All these are semi-synthetic polymers. Understood? Let's move on to the next. Next classification is based on the nature of monomer unit. For example, if both the monomer units are same, if all the monomer units are same, it is called a homopolymer. Homo means same. Example is, if we took ethene and I keep connecting ethene together, then what will I get? I will get a polyethene. So it is a homopolymer. Similarly, the next kind of polymer is a copolymer, where I attach two different kinds of monomers together to form a polymer. For example, one monomer is 1,3-butadiene. I connected with acrylonitrile. So these are two different monomer units, isn't it? And when I connect them together, I get the polymer of butadiene acrylonitrile, also known as BUNA-N. Very, very important example. This is an example of a synthetic rubber. Okay? Rubber that is found in nature also. From trees you can extract rubber. From which tree do you extract rubber? Let me know in the chat box. From which tree can you extract the rubber? Right? So let me know in the chat box. I'm not going to tell you because this you've been studying since you were very, very young, and right now you are preparing for your JEE Advanced exam. I want you guys to know which tree is responsible for the rubber, right? And Buna N is a synthetic rubber which is a copolymer of these two monomer units. Understood? Next is the classification on the basis of structure. Structurally, how they are. Are they linear in a single chain? If they are linear, which means what? They are long chain of atoms. Okay? They are also one-dimensional polymers. Okay? They look something like this. For example, this is the monomer unit. When you polymerize, if it condenses into a linear polymer. Okay? This is a linear polymer. Examples are polyethylene, PVC, nylon and polyester. These examples are very important because your JEE along with the application part will also focus on a little bit of your memory part. So you have to remember which is a linear polymer. Similarly, branched polymer. Branched polymer are what? These are low density polythene. Very good example of branched polymer is a low density. Ma'am, what do you mean by that? I will explain it to you in just some time. Just keep this in mind for now. Okay, branched looks like this. They are linear only, but through them some branches are coming out. Okay, these are branched polymers. Next is three-dimensional polymers. Three-dimensional polymer, what happens? They are cross-linked. These are cross-linked chains. Example is bakelite. Now, what is bakelite now? I will let you know. Just keep this in mind, okay, on the basis of structure, on the basis of what kind of polymerization is there, on the basis of sources. Okay, these polymers are classified. Okay? Now, bacha, for your 3D structures, they can either be like this cross-linked polymers. Cross-linked, what is happening? There are linear chains. So many linear chains, but they're connected to each other via some linkage. Can you see? Via some linkage they're connected. So these are cross-linked polymers. Similarly, what are network polymers? They look something like this. They form a network with each other. Understood? Let's move on to the next. Classification is on, very important is this, on the basis of molecular forces. What kind of molecular forces exist? Is it strong? Is it weak? If it is weak, is it van der Waals? If it's strong, is it H bonding? Is it dipole-dipole interaction? Based on that, we have classified the polymers. Number first is the elastomer. As the name suggests, elastic. What comes to your mind? Ki ma'am, when I stretch it, it comes back to its original position. After I leave it, it comes back to its original position, isn't it? Yes. Rubber tree, somebody is saying, ma'am, the rubber tree is what? Kerala tree? No. Kerala tree is not the name. Oh my God, bacha, no way. Okay, elastomers are what? They have very weak intermolecular forces. That's why I can stretch it, right? It is able to stretch because they have very, very weak intermolecular forces. They have elastic character. What kind of character is there? Elastic character. It can be stretched up to 8 to 10 times of its length. 8 to 10 times. Okay, these are amorphous. These are linear and soft. Okay? And a very few crosslinks are present. I just made you understand what a crosslink. This is a linear chain, and some crosslinks would be present somewhere. And these crosslinks are what is providing its elasticity, which means after you leave it, it comes back to its original position. Yes. Why? Due to these crosslinks are very, very important. Okay? What is the example of elastomer? Natural rubber or synthetic rubbers like Buna S, neoprene, etc. So this is the example of neoprene. Neoprene molecule looks like this. There is a chlorine at the second position. This is the kind of elastomer. Understood? Let's move on to the next, which is fibers based on molecular forces. So in elastomer, the molecular forces were very weak. What happens in fibers? They have strong intermolecular forces. Why? Because they either have hydrogen bonding or dipole-dipole interactions between them. So what is happening? These are linear chains. In between the linear chains, there is either H bonding present or either dipole-dipole interaction would be present. That is why these fibers are what, bacha? These have strong intermolecular forces, due to which this also leads to crystallization of them. Okay, these are thin, long, rigid. Rigid, why? Because they have hydrogen bonding and dipole-dipole interaction. They have tensile strength, which means what? I can stretch them. If I stretch them, they will not break easily. So they are tensile. Mechanical strength, same. If I continuously hammer them, they won't break easily. So they have mechanical strength. They have tensile strength, right? What are the examples? The examples are your fibers that are found in your clothes. For example, nylon 6 and also nylon 6, nylon 6, nylon 610, terylene, polyesters, polyacrylonitrile, PAN. So mostly polyesters are the example of your fibers. Understood? Okay. Next is here. Next, based on intermolecular forces, are your thermoplastics. So I just discussed two kinds. Number first was your elastomer, where they have the very weak intermolecular forces. Fibers had strong intermolecular forces, which were either hydrogen bonding or dipole-dipole interaction. Next kind is thermoplastics. What happens in here? That they have intermediate intermolecular forces. They are neither too strong and nor too weak, right? But what happens with thermoplastic? That it gets soft in heating. As I heat it, it gets soft, so that I can mold it. I can just make it into any structure. After it cools down, it becomes hard once again. And I can repeat this process as many times as I want. I can heat it, then once again it becomes soft, then I can mold it into any shape I like, then once again it becomes hard. After that, also I can heat it and then again make it into any shape I want. So that is the property of thermoplastic, that it can be molded into any desired shape and also any number of times. How many times you want? Okay? What is the property? That these are linear, once again straight chain, these are soft, these are soluble in organic solvents. What are the examples? Polyvinyl chloride, PVC, polyethylene, all the linear structures that we studied, polypropylene, polystyrene, PMMA are the examples of thermoplastics. Understood? These are thermoplastics, intermediary, they have forces of attraction. Next is what? Thermosetting, last property, last kind of classification on the basis of molecular forces. So thermosettings are what? These can also be molded into any particular shape on heating, but it can be done just once. Only one time you can heat it and then make it into any shape, and once it cools down, it will harden, and then once again you cannot heat it and make it into another shape because it will collapse. It will not happen. So this is the property of thermosetting polymer, that they set into rigid shape on cooling. Okay? Cross links are there in between them. In thermosetting, in thermoplastic, what was there? There were linear soft chains. Here, what is present? There is cross links present in thermosetting polymer. So therefore, they have a 3D network. That is why they are what? That is why they are hard, they are brittle, and they are insoluble in organic solvents. What are the examples? Examples are bakelite, aniline aldehyde resin, urea formaldehyde polymer, melamine, etc. Now, ma'am, what is bakelite? What is urea formaldehyde? I will tell you structure of each of these. Whatever examples we discuss, we will also discuss their structure, their polymer, how are they made, everything. Right now, just keep in your head on what criteria are these classified. Understood? So the next criteria is over based on molecular forces. Okay? Now the next is the mode of synthesis, another kind of classification. How are they synthesized? So they can be synthesized as either addition polymers or your condensation polymers. What are addition, bachcha? In addition, what is happening? Simply two monomer units are adding together. I am one monomer unit, then one again comes here, I hold its hand, one another comes here, I hold its hand. So we keep on adding. There is nothing subtracting from me. I am subtracting nothing from me. So I am just keep on adding too many molecules. These are addition polymers. What are condensation? In condensation, bacha, what happens? For example, you have studied about your protein, isn't it? So when you study about protein, how a protein mates through amino acids. So what happens? COOH of one amino acid and NH2 group of another amino acid react together, and what happens? H2O molecule is left. Okay? H2O molecule leaves, isn't it? So what happens? Minus H2O happens and your amide bond is formed like this, CONH2, isn't it? Isn't it? So what is happening in proteins, in amino acids? What is happening? That a water molecule is getting subtracted and an amide bond is formed after that. So this is the best example to understand condensation polymer. So there is some molecule that is leaving. The molecule can either be a H2O molecule, a NH3 molecule, a HCl molecule, or a alcohol molecule. So small molecules will leave, will get eliminated in condensation polymers. Understood? Next is nothing. So we have already discussed that nothing is lost during polymerization. Addition polymers, small molecules like this are lost. Okay? Generally involves one type of monomer. Yes, very important. In addition polymers, generally what happens? In most of the cases that there is only one kind of monomer unit. For example, if it is ethene molecule, then too many ethene molecules will connect together, right? But in condensation polymers, what happens? There is at least two types of monomer units. I mean, there can even be one, for example, in your proteins, right? But what happens? There is more probability of having two different kinds of monomer units. Understood? Next is the monomers are generally unsaturated compounds. Yes, they need to be unsaturated, means what? They either have a double bond or a triple bond between them. Very essential. If it doesn't have unsaturation, addition polymers will not take place. So what is the requirement? There should be some unsaturation present. Similarly, for condensation, what is the requirement? That there should be at least two kinds of functional group. Two functional groups must be present. Very important. Two kinds of functional groups must be present. Understood? Next is, what are the examples? So these are the important criteria. What are the examples? Are polyethylene, polypropylene and PVC are the example of addition polymers. Condensation are once again nylon 6, terylene, bakelite, etc. And you will not have to like rectify the examples because we're going to look at its structure. After looking at its structure, you will automatically understand, ma'am, this is actually condensation polymer and these are actually addition polymers. Okay? Right now, we're just focusing on the classification. Then I will let you know the structures, and then when you come back to these classifications, you will automatically understand everything. Okay? Next is types of polymerization. Polymerization reaction. Can you see? So right now we have discussed all the classification of polymers. What can it be on the basis of from where they are extracted? Are they natural? Are they synthetic? What is its shape, ma'am? What kind of monomer units are used, right? And is it a addition polymer? Is it a condensation polymer? What are the intermolecular forces between them? So we've discussed everything. Now we're coming back to how do they actually react? How do the monomer units react to form a polymer? So there are two ways. The two ways are the addition and the condensation that we are already read. Okay? In addition is also called, addition polymers are also called chain growth polymers, where one polymer keeps on adding. Monomer units keep on adding. These are also called chain growth polymers. Okay? Next type is condensation or step growth polymer. Understood? Now let us look at it one by one. Addition or chain growth. These are once again can occur in three types of reactions. It can be either a cationic polymerization, anionic polymerization, or free radical polymerization. Understanding? Three kinds of reactions can take place. Mechanisms can take place for addition or chain growth. So what is, ma'am, cationic? Very simple once again. So in cationic, bacha, what happens? The requirement is, because we're talking about addition polymers, what did I tell you? That there should be some unsaturation present. Very, very important, isn't it? Unsaturation is very, very important. So first type is cationic. In cationic, after you take acid or a Protein-Lewis acid catalysis, which means what? That there should definitely be a presence of an acid there. Okay? Then only a cation can be formed, isn't it? So what did I take? After, for example, here, this kind of cation is formed after the acid. Then what is happening? This cation is being acted upon by the double bond. Why? Because the double bond is your electron-rich species, isn't it? Because this is a pi bond. This is an electron-rich center, right? So this will attack the positive charge. Then, bacha, what will happen? This kind of carbocation is formed. Then, bacha, what happens? This keeps on adding. Then once again, another CH, double bond CH would attack this, and this keeps on adding, right? So can you see how polymerization is taking place? Okay? This kind is called the cationic polymerization. Next is anionic. Anionic means what? Once again, an anion will be formed because it is addition polymerization. Therefore, we know that there should be a presence of a unsaturation, like a double bond is present over here. Now, what is the property of anionic? When it will happen? So, whenever there is an electron withdrawing group, can you see a CN is attached over here, right? So, whenever there is an electron withdrawing group attached to the unsaturation, then definitely what process will happen? Anionic polymerization would happen. Okay, understood? So now, bacha, what is happening? Can you see this kind of thing? Then what will happen? Anionic polymerization is happening. This base is attacking this hydrogen over here. Then what happens? An anion is formed on this, and after that, once again, this step keeps on repeating, and this kind of polymer is formed. So what is the thing that you have to keep in mind? That in your addition or chain growth in anionic polymerization, if there is an electron withdrawing group like CN is present, then definitely what will happen? Anionic polymerization will happen. Understood? Understood? Next kind. Let us move on to the next is free radical. What happens in free radical mechanism, bacha? There should be a free radical generator catalyst. What are the free radical generators? These are peroxides. Any peroxide can be benzoyl peroxide, can be acetyl peroxide, and can also be your tertiary butyl peroxide, isn't it? Whenever you see in your reaction a peroxide is there, then definitely if the addition polymerization is happening, then bacha, free radical through free radical step, the polymerization will take place. So again, we know that free radical reaction happens in 3 steps. First step is the chain initiation. Then is the chain propagation. Then last step is the chain termination. We also read it in your haloalkanes and haloarenes chapter, isn't it? When we are reacting chlorine in presence of light, that reaction is also a free radical step. So the free radical mechanism is similar throughout your organic chemistry. So once again, first step is chain initiation, where what happens? We took a benzoyl peroxide, then the bond breaks from the middle and a free radical is generated like this. Then what happens? This CO2 gas goes away and a phenyl radical, free radical is generated. Now what is happening? This phenyl free radical now attacks the double bond, and once again another free radical is generated. Okay, so this is chain initiation. stops here. Then after what happens? Chain propagation. Next step is chain propagation. So this free radical attacks another unsaturated ethene over here and makes more longer free radical, then longer free radical, then longer free radical, keeps on happening. So ma'am, how will this chain stop? Then bacha, the last step is chain terminating step, where what happens? Two kinds of free radicals when joined together, two different chains that are formed, two different free radical chains that are formed, they join together and the reaction stops. This is called chain termination step. Understood everybody? ठीक है? Next is examples of addition. So we have studied right now कि there are two kinds of polymerization reactions. One is addition, next is condensation. So first of all, we dug into the addition polymerization. What was happening in addition? That bacha, there were three kinds of polymerization: cationic, anionic and free radical. Understood? Now we are looking at the examples of addition polymerization. We looked at the process, we looked at the mechanism. Now let us look at the polymers that are formed through addition polymerization, right? So number first, very important example is the styrene molecule. ठीक है? Generally also read at the above line that generally vinylic monomers. What are vinylic? This kind, ठीक है? This kind of, whenever something is attached directly to the double bond, right? These are called vinylic substituents, right? So vinylic monomers undergoes this route via free radical polymerization. So what it is going to say, whenever you see any group attached to this directly to the double bond, it is called vinylic position, right? So whenever you see this bacha, then free radical polymerization will happen. Now let us look at the very first example of your addition polymerization. Can you see styrene? So what is the speciality of styrene once again? Can you see this is a double bond, right? And a phenyl ring is directly attached to the double bond. Therefore, this is once again a vinylic substituent, isn't it? So therefore, what is happening? Free radical polymerization will happen, and also here a free radical is generated like a peroxide. Then what is happening? This free radical, this kind of process happens. So what happens? This also gets generated into a free radical. This free radical now attacks the double bond over here, and the chain becomes longer, and this keeps on happening and the polymerization is taking place. Okay? So through free radical mechanism, this happens. This is the example of styrene. What this is? This is the styrene polymer. Okay? Next is examples of addition polymerization are another. So we read about one kind, vinylic. Vinylic means what? Whenever there's a double bond and right next to the double bond there is some group attached. So these kind of polymerization of molecules will undergo addition polymerization, isn't it? Next is other examples are polyethylene or polythene. ठीक है? Once again, polyethylene, very important example of addition. And polythene is actually of two types. One is low density polythene, next other one is high density. I'm going to tell you the differences between these two very soon. Next is your polytetrafluoroethylene Teflon or PTEE. ठीक है? Next kind is PAN, which is also called as polyacrylonitrile or Orlone. Next is PVC, polyvinyl chloride. So these are four types. These are the four very good, very popular examples of addition polymerization. Let us look at them one by one. So low density polythene. I told you there are two kinds of polythene. One is low density, other one was high density. So what is the difference? The difference is how they are prepared. For example, I took a ethylene molecule and I gave it a pressure of 350 to 570 Kelvin, high pressure, for example 1000 to 2000 atmosphere. Then I get a low density polythene molecule. What it is? It is a straight chain. Sorry, it is a straight chain molecule and it has some branches. Can everybody see? There are some branches popping out of it. Okay, it is mostly a straight chain, but there are some branches popping out of it. Okay, what is the property of low density? That it is chemically inert, but it is tough, but also a little bit flexible, and it is a poor conductor of electricity. And therefore, what can be its uses? Its uses are, it is used in insulation because it cannot conduct electricity, because it is flexible, so it is used in squeeze toys, and also in making of flexible pipes. Okay? So this is the uses, properties and preparatory methods of low density polythene. Let us look at high density polythene. Once again, can you see the temperature here? The temperature here was 350, here once again 333 to 350 Kelvin the temperature can be, but the pressure is low this time. Can you see? In last reaction we used 1000 to 2000 atmosphere pressure. Right now we're using just 6 to 7 atmospheric pressure. But high density polythene is actually prepared in the presence of a catalyst called as Ziegler-Natta catalyst, right? And same polythene is made, but right now this time the polythene that is prepared is actually a high density polythene, right? Understood? Okay. Now bacha, what is happening? What is Ziegler-Natta catalyst? Very important question. The answer is triethyl aluminium plus titanium chloride forms your Ziegler-Natta catalyst. Very, very important. Mark this down. Okay. And what is the property? The property is these are linear molecules. I know you cannot read it, but I will tell you. These are linear molecules once again. Can you see that there is no branching? No branching is present, right? So what does it mean? That whenever it's a linear molecule with no branches, okay, then it is a very tough molecule, okay? And it has high density due to close packing. They have very close packing, therefore they have high density. So these are once again chemically inert, but they are more tough than the low density polythene and they are hard. So they are used in buckets, dustbins and bottles. Is this thing clear to everybody? Let's move on to the next kind of addition polymer, which is PAN, polyacrylonitrile. How it is prepared? What is the monomer unit? The monomer unit is vinyl cyanide once again, or it is also called as acrylonitrile. Then in the presence of a peroxide catalyst, what we get? We get a polyacrylonitrile. So you need to know that what are the monomer units of PAN. The monomer unit of PAN is this, vinyl cyanide. And the polymer that you're getting is a polyacrylonitrile. And what it is used for? It is a substitute for wool. Okay? Again for making clothes. Okay? Next is polytetrafluoroethylene, PTFE. So this is a structure tetrafluoroethylene. Okay? All the hydrogens are replaced by fluorines. So that is tetrafluoroethylene. And when I use a catalyst under high pressure, I get Teflon. A very common product right now in this day and age, isn't it? Okay, and here to prepare this, we usually go through the free radical route. And what is the free radical generator that we're using? It is a persulfate catalyst. Right now, there's not a peroxide, but a persulfate catalyst. For example, ammonium persulfate like this can be used. Okay, what are the properties of PTFE? Very important molecule. It is inert. It is resistant to attack by corrosive agents. Therefore, what can it be used for? Because it cannot be corroded. So it is used for making the oil seals and gas gaskets. So whenever there is a gas leak, gas is so popular for causing corrosion, isn't it? Oil and all of that. So oil and gaskets it is made, and it is also used for making the non-stick pans, as I told you, right? Non-stick pans are made of PTFE too. Okay? Next is polyvinyl chloride. Polyvinyl chloride, what is the monomer unit? Monomer unit is a vinyl chloride. See, this is the monomer unit. Here the chlorine is present. Here is a double bond. So C double bond C Cl. When I polymerize it, I get a PVC product. What it is used for? It is used for making raincoats, handbags, insulating wires, and also gramophone, because it has several uses. PVC is like very common, used for several uses. Okay? Let's move on to the next thing, which is natural rubber. Once again, it is made by addition polymerization. Very important. So what is the monomer unit of natural rubber? It is actually isoprene. What is the monomer unit of natural rubber? Isoprene. Isoprene is what? It is 2-methyl 1,3-butadiene. What it is? 2-methyl-1,3-butadiene, very, very important molecule. Now, once again, this molecule can either be a cis or a trans molecule, isn't it? So, for example, this is the cis form and this is the trans form, the below given. Right? Cis means along the double bond, both the alkyl groups are at the same position, right? But the trans form is along the double bond, one alkyl group, for example, this is the double bond, then one alkyl group is below, the other alkyl group is below, above and below, right? So this is a trans. So whenever we are using the cis forms, bacha, whenever we are using the cis form, then bacha, it is called the natural rubber. Okay? Cis or the Z form. But when we are using the trans form of isoprene, isoprene is 2-methyl-1,3-butadiene, then what we get is a gutta percha. What do we get? A gutta percha. You might not be understanding what is happening. I'm going to draw it. For example, I took this molecule 1, 2, 3, okay, and here's a double bond, and here is this, and here is once again a double bond. So this is your isoprene molecule. Okay, now bacha, what can happen? For a 1,4 addition to happen, I've taught you this whenever I took the your organic chemistry question answer session. So many I've done, and in so many of them I have taught you that whenever a butadiene kind of structure is shown to you, what is butadiene? This kind of structure, double bond, single bond followed by double bond. Once again, very important kind of reactions happen with them. What reactions? 1,4 reactions happen. What does that mean? It means that these two double bonds, for example, this double bond can travel here and the charge, negative charge gets traveled over here. So what actually happens, a double bond travels over here, okay, and this will remain here as such, and the new group that is going to attach will attach either at the 1 position or at the 4 position. For example, I write it 1 and I'll write it here 4. So 1,4 additions take place in your butadiene kind of structure. Okay? Now can you see, when I make the 1,4 product, then that 1,4 product can either be a cis product like this, or it can either be a trans product. This will come here, this will come here, right? So this is a trans product, sorry, yes. So this is a trans product that is formed. The other product that I can form is a cis product like this. So one addition happens over here. The 4th addition happens over here. So this is the cis product and this is the trans product. Right? Right? So can you see two kinds of products I can form out of this isoprene due to what kind of addition? 1,4 addition. 1,4 addition happens. What kind of reaction happens? 1,4. For example, one group gets attached at the 1st position, the other groups get attached at the 4th position, and there remains just one double bond in between them. This is a very important class of reactions. We read it while we are studying in organic chemistry, reactions in organic chemistry. So the same funda is followed over here. So when cis product is formed, it is the natural rubber, but when the trans product is formed, it is again a natural rubber once again, but the name right now is gutta percha. What is the difference between them? Let us see. Study. Both of them are elastomeric, okay? Both of them have weak intermolecular forces because these are both rubbers. Okay? A few cross links are introduced in the shape. So whenever in these natural rubbers, what do? We introduce a few cross links. This is the natural rubber, and I'm introducing a few cross links which are essential to provide the elasticity, so that when I stretch it and leave it, it comes back to its original position. It is possible only due to these cross links. So naturally, the rubber is not that elastic. That elasticity is introduced artificially from outside. Okay? Now, what is the difference in gutta percha then? Then gutta percha, bacha, is a little bit of brittle. Gutta percha is little bit more brittle in nature. It breaks very easily. Which form? The trans form. And here in both of them, what addition happens? 1,4 addition happens. Understood? Understood, everybody? Everybody. Somebody is asking, ma'am, how can we identify? Beta, I just taught you how can you identify cis or trans. Right? Right? If the cis product is formed around the double bond, both the alkyl groups are the same position, right? If the trans product is formed, then the alkyl groups are this. But if your question is, ma'am, in the exam just isoprene is given to me and I need to make the polymer out of it, then you will make both kinds, because through isoprene both kinds are possible, the cis form as well as the trans form. That's why I've showed you this together. Understood? Understood? Somebody is saying, ma'am, will you take the theory part? Beta, I will let you know. See, if you want to learn from me, okay, then please, all the updates will be available on this Telegram channel. Whatever happens, Nandini JEE. Okay? Whatever happens, if you want to ask me anything, please connect with me on Nandini JEE for the advanced section. For your next month preparation, I will let you know. I will let you know. There's a whole lot of things that I want to tell you. Okay? Next is this. Vulcanization. What happens in vulcanization? Again, it's a rubber. We're talking about rubbers only. Vulcanization is, once again, we are delving into the synthetic rubber section. So what we're doing? We are synthesizing rubber. Synthetic rubber. Okay? So what is vulcanized rubber? So once again, you took this kind of molecule. This is what, once again, your isoprene molecule or a kind of it. But here you have introduced sulfide bridges. So these sulfide bridges are very, very essential to give the rubber strength and elasticity. Okay? If 1 to 3% of sulfur is used, it is used in hair bands, which girls use to tie their hair, right? So here only 1 to 3% sulfur is there in that rubber. But the tire on which your motorcycle or your car runs or your cycle runs, they have 5% of sulfur in it. Understood? Very, very important criteria for vulcanized rubber. Next, difference between natural and vulcanized rubber. So once again, natural rubber is soft and sticky. Okay? It's a sticky substance when it comes out of the tree. But the vulcanized rubber is hard and it is non-sticky. Okay? And natural rubber has low tensile strength. What does it mean? That when I stretch it, it will break very easily. Low tensile means if you stretch it, it breaks. Okay? But your vulcanized rubber has high tensile strength. Once again, natural rubber has elasticity. Okay? But high elasticity is present in vulcanized rubber. So vulcanized rubber is very elastic. Elastic means when I stretch it and leave, it comes back to its original position. That property is better in a vulcanized rubber. Okay? It can be used at a narrow temperature range from 10 to 60 degrees Celsius. If you heat it, it will lose its elastic property. But vulcanized rubber can be used from minus 40 to 100 degrees Celsius. So when your vehicle runs, your car runs, when your tires are sliding on the road, what is happening? They're heating up as well, but they're not melting down. Why? Because they are vulcanized rubber. Okay? It has low wear tear resistance. It means it can wear tear easily. But your vulcanized rubber has high wear tear resistance. Okay, it is soluble in solvents like ether, carbon tetrachloride, petrol. It is soluble in all common solvents. Understood? Moving on to the next. Next, synthetic rubber, more examples. So I just taught you in synthetic rubbers, what do? They take the natural or the equivalent of a natural rubber and introduce sulfide bridge in it, and that is called vulcanization. A very, very important process asked many times in your exams. Synthetic rubber, very first example is cis polybutadiene. You took butadiene molecule, right? Once again, 1,4 addition happens. So by 1,4 addition, you get cis polybutadiene molecule, one kind of rubber. So what is the thing that you are experiencing in this rubber? So whenever a butadiene molecule is there, right? So what is the common thing in rubber? So whenever this kind of molecule, no matter what is attached, can be a chlorine attached, can be a isoprene kind of molecule, isn't it? So whenever a butadiene is there, what you are going to get? You are going to get a rubber. Understood? Okay. Next is neoprene molecule. In neoprene, there is a chlorine at the second position, but it's once again a butadiene molecule, and you get the rubber that you get is called a neoprene rubber. It is synthetic rubber. Next is buna-N. Buna-N, once again, you take a 1,3-butadiene and you react it with this nitrile molecule. Okay, vinyl nitrile molecule. And right now we're doing copolymerization, which is we are attaching two species. But once again, this is not condensation polymerization. Why? Because no molecule is leaving. We're just adding. There is no elimination happening. Just addition is happening. So this is only addition polymerization, but of two kind of monomer units. Once again, 1,4 addition happens, and the rubber that you're getting is called buna-N, because butadiene is there plus your vinyl nitrile is used. Buna-N. The last kind of synthetic rubber is buna-S, where you take butadiene once again and you react it with styrene molecule. Styrene plus butadiene will form the buna-S molecule. All the uses are given here. You can go through the PDF. Okay? So, but I'm explaining the important things that you need to know. Next is condensation polymerization. So, condensation polymers, for example, what are the examples of condensation polymers? Let us look at this example over here. For example, I took a ethylene glycol. Glycol has what? The OH group, alcohol group. Plus, I took the benzene 1,4-dicarboxylic acid, also known as terphthalic acid. So, it has the acidic group. Now, what is the reaction happening? When I react alcohol with acid, what do I get? I get a ester molecule. Same thing will happen over here. So what is happening? H2O will leave from here. H from here and OH from here will leave, isn't it? So minus H2O will happen. So because one molecule is getting eliminated, then I'm getting a ester molecule here, isn't it? This CO bond is I'm getting from here. So ester is formed, ester molecule polymer is formed, which is called terylene or dacron molecule. And this is how condensation reactions happen. Another name for condensation reaction I just taught you was step growth polymerization, isn't it? Addition polymerization was called chain growth polymerization. This is called step growth polymerization. Understood? So this is how your condensation polymerization happens. Now what are the examples of condensation polymers? The examples, they can be either polyesters, for example the ester bond formed over here, or they can be polyamides which have CONH2 bond over here, or they can be phenol formaldehydes, or they can be melamine formaldehyde resins. We'll look at all these examples one by one. ठीक है? Next is this, condensation polymers. For example, glyptyl. In glyptyl, what I'm taking? I'm taking a glycol molecule which has a alcohol group plus a phthalic acid which has a acidic group. Now, when I'm connecting these two, when I'm condensing these, I am losing the H2O molecule, and what I'm getting? I'm getting a ester molecule, isn't it? So, glyptyl is a ester. So, all the polyesters are formed through your condensation polymerization. Number first example is glyptyl. Very, very important monomer units. What are the monomer units of glyptyl? Ma'am, it is ethylene glycol plus phthalic acid. ठीक है? Next, condensation polymer nylon 6,6. Once again, nylons are what? Out of your clothes, and these things are made up of. है ना? So fibers are made up of nylon. We all know that, very, very popular brand of clothing, nylon. So nylon 6,6 is actually a polyamide. What it is? Polyamide. So what I want to tell you, that nylons, your clothes, are generally what functional group is there? These are polyamides. है ना? So what is happening? When acids and amines, ठीक है? Adipic acid and hexamethylene diamine react together at high temperature and pressure to form nylon 6,6 molecule. 6,6, why is it called? Because adipic acid is also a 6-carbon acid. Similarly, your hexamethylene diamine is also a 6-carbon amine. That is why it is called a nylon 6,6 molecule. And this kind of amide bond is present between these two. What is eliminating? Again, H2O gets eliminated. That's why it's a condensation polymerization. Next kind of condensation polymer is nylon 6 molecule. What is the monomer unit? The monomer unit is caprolactam. Caprolactam is made up of 6 carbon atoms, and it is a cyclic molecule. 1, 2, 3, 4, 5, 6 plus a NH group, right? So this amide group is present already. And when I do its polymerization, then I get this kind of aminocaproic acid. And after this, after eliminating H2O, I get aminocaproic acid, and then after I heat it at high temperature, I get a nylon 6 species. Okay, these is very, very important because it is very, very strong that it is used for making tire, cords, fabrics and ropes. Ropes which are very, very strong, right? These are also made up of your nylon 6 molecule. Okay? Next is nylon 11. As the name suggests, how many carbon atoms will be there? 11 carbon atoms. So it is actually omega amino undecanoic acid. Undeca is the IUPAC name of 11, isn't it? Undeca is the IUPAC name of 11 number. है ना? So because 11 carbon atoms are there, that's why it's called nylon 11. And when I heat it, I get a nylon 11 molecule. Understood? These are condensation, polymerization. Now we are talking about the phenol formaldehyde condensation polymer. Very, very important. Okay? So I took a phenol and I reacted with formaldehyde, and then in the presence of either acid or base, what can happen? I can get this kind of phenol formaldehyde molecule. Formaldehyde molecule. Now this reacts with itself and it can form these kind of formaldehyde resin. Okay, very, very important once again. See, so many can be formed. One CH2H is attached here, the other gets attached here, and the other molecule, the CH2H gets attached at all the positions. Okay, now these can combine together to form a polymer. Okay, these are phenol formaldehydes. Next is, once again, you took a phenol formaldehyde. I'm talking about novolac. So the last here we discussed the phenol formaldehyde. Here what I'm saying that these are the monomer units. When I attach phenol with formaldehyde in presence of acid or base, I actually get these three kinds of monomer units. One, it is only at the ortho position, then it's the ortho and the para position. In the next, I'm getting at the two ortho and one para position. So three kinds of monomer units I can get when I react these two species. Now, what is the polymerization? Now, there are two kinds of polymerization that can happen with these units which we just created. For example, with phenol formaldehyde, I got this unit and this unit, and when I attach these in linear fashion, can you see just linear fashion, then the polymer that I'm getting is a novolac polymer. What polymer? Novolac. It is a linear product, and as the name suggests, very, very important brand of paints. है ना? Narrowlac, Novolac. So it is actually derived from this. So Novolac is a very, very important polymer for paints. Similarly, this phenol formaldehyde, what I'm getting, instead of linear structure, I am making a network solid like this. All the CH2OH gets connected with each other and form a network solid, then it is called a bakelite molecule. Understood? So the monomer is same, which is phenol plus formaldehyde I'm reacting. Now at which positions the formaldehyde got added and in what fashion the polymerization happened. Whether it is a linear polymerization, whether it is a network polymerization, based on that, what is happening? The kind of polymer is changing, right? So the linear one was called your novolac and the network one is called your bakelite. So there is almost obviously a difference. Bakelite is very, very popular thermosetting polymer, which means what? That once you heat it and you make it into some shape, the next time you heat it, you cannot again remold it into another shape. It will just break. It will just fall apart. So only one time it can be heated and made into one shape. The next time you heat it, it will fall apart. It will not take place. Okay? So it can never be reused or remolded. What it is used for? It is used for making combs. Okay? Phonograph records, electrical switches and handles of various utensils. So all the tough things are made up of this kind of bakelite molecule. Okay? Next, let's move on to the next condensation polymers. Next kind is melamine formaldehyde resin. What is melamine? This is the structure of melamine. where 3 carbon atoms are replaced by nitrogen groups. It is kind of a benzene ring, but 3 carbon atoms are replaced by nitrogen groups, and to the other carbon atoms, amino group is added. So this is a melamine molecule. When I react melamine with again formaldehyde, what do I get? I get an intermediate like this, and then when I do its polymerization, I get the melamine formaldehyde polymer. It is similar as your bakelite polymer, but here the monomer unit changed. There I use phenol, here I am using the melamine instead of phenol. The other is same. So this is once again the melamine formaldehyde resin. Okay. Next kind of polymers are your biodegradable polymers. Very important question from your JEE perspective. They love biodegradability, isn't it? So, bacha, for biodegradable polymers, number first is the poly-beta hydroxybutyrate or co-beta hydroxyvalerate. I know it's a big name, but so its small name is actually PHBV. So first, very first kind of biodegradable polymer is PHBV, which stands for poly-beta hydroxybutyrate co-beta hydroxyvalerate, right? So what are the monomer units for this? It's a 3-hydroxybutanoic acid plus 3-hydroxypentanoic acid. Butanoic acid plus pentanoic acid react together to form PHBV. Understood? Very important class of biodegradable polymer. Next biodegradable polymer, very important, is nylon 2, nylon 6 polymer. As the name suggests, first amino acid is formed of 2 carbon molecules, isn't it? Glycine. First is glycine monomer unit plus amino caproic acid made up of 6 carbon molecules, right? They react together to form nylon 2, nylon 6 molecule, and we know that, ma'am, in nylon there will always be a amide linkage, so therefore there is a amide linkage here as well. It's a polyamide. Nylon molecules are polyamide. So nylon 2, nylon 6 is a kind of polyamide condensation polymer, but it is a biodegradable polymer. Understood? It is a biodegradable polymer, isn't it? Okay? Okay, next is here. We have completed. Congratulations, we have completed the polymer section. None questions will come other than what I've taught you. I am very 100% sure, because for questions from polymers are mostly theory based. Even if you go through the previous year questions, you'll find only 4 or 5 questions being asked in the entire JEE Advanced section. I know this is a not so important section, but we cannot miss out on those marks as well. We cannot be taking risk in life, especially when JEE Advanced, such a big exam, is actually on the edge, right? So that was everything I have to tell you about your polymers, polymerization reactions, examples, what you need to know, right? What are the monomer units? Most of the questions are asked from that. Also, the other kind that you should know is when you break one polymer, right? What will be the monomer units generated from that? This is a very important kind of question. For example, they'll give you any monomer unit. I just explained it to you. For example, I will take a new page. For example, this kind of monomer unit is there. This kind of, they gave you, sorry, not a monomer unit. For example, CH3, CH3. Here is the, no. I'll not give you this erase all ink. I will show you this kind of molecule. This is C, double bond C, and then here's a C. Here's a CH3. Here is the CH3. Okay, this kind of thing is given to you. Here's a chlorine molecule over here. Okay, they have given you this. They've given you this. Now they're asking you what is the, this is a kind of polymer. This is a polymer unit given to you. The polymer unit will not look like this. One second. Where's the pen? Here's the pen. Here is the butadiene molecule. I'm trying to form one molecule. This is a CH3 molecule, right? And here is the N, correct? Here is, for example, there is a Cl molecule here. For example, the Cl molecule here. And for example, there is a CH3 molecule over here. Okay? This kind of molecule is given to you. Yes, this is correct now. Now they're asking you, this is a polymer. If this is a polymer, what will be the monomer units? What are the monomer units of this molecule? Can anybody tell me? Can anybody tell me? Can I give you this as homework question? Very, very important. Very, very important class of question. This kind of polymer is given to you. And in your question, they are asking you, let me know the monomer units. What is the monomer of it? Very, very important question. If you want to know the answer, if you cannot follow, I think most of you can predict the answer. But still, if you want to confirm, again, you know where to reach me. Nandini, JEE, right? I will let you know how to approach these questions. But first of all, I want you to use your own brains, because once you figure out a question on your own, you will love it even more. Isn't it? Isn't it? ठीक है? Hi, bacha. What are you trying to say? What are you trying to say? Chalo, next. Next, we're talking about chemistry in everyday life. This is the last chapter of your organic, right? Which was not there in the JEE mains, but will definitely come in JEE Advanced because it was not there. So there is high chances of coming in JEE Advanced to filter out more students, right? So that is a strategy they follow, and you should right now know what strategy they are going to use. So first of all, in JEE Advanced, chemistry in everyday life, drugs, once again, very easy chapter. We're going to complete it within 20 minutes now. So what is the definition of drugs? So bacha, drugs are low molecular masses chemicals. Very, very important. These are chemical compounds, but they have very low molecular mass from 100 to 150 units. ठीक है, 100 to 150 units in which your chemicals are measured. So it's only 100 to 150 units. ठीक है. What are drugs? So bacha, when drugs are acted on macromolecular targets. What are macromolecules? Bigger molecules in my body. Drugs are used for my body. Plants do not take drugs. We do spread pesticides on them, I know. But still most of the cases, what is happening, pesticides are also working on the similar fashion only. Okay, we are going to come back to that. So drugs plus macromolecular targets is equal to biological response. When I take any medicine inside my body, what is happening? There is some receptor, a protein, a big enzyme is there in my body on which that drug just attaches itself. For example, this is the receptor in my body. The drug will attach, and when the drug attaches, what it is causing? Some kind of biological response. For example, if I'm sick, it will cure me. And if I'm not, for example, when people get old, they're unable to fall asleep, then what happens? They take drugs, right? So those drugs help them to sleep. And which means what? That when I'm taking some medicine, what is happening? I'm able to sleep. It is causing some biological response in my body, right? So drugs are helpful for causing biological responses. Okay? Next is, what is the medicine? So drugs can be anything. They can be good, bad, right? There are bad drugs as well. I know, I'm sure you are familiar with bad drugs as well. So when the drug is called a medicine. Okay? So drugs are called medicines when they are useful in diagnosis. If it is able to tell there's some problem in me. Okay? It is useful in some prevention or treatment of diseases, and a dose consumed higher than the recommended can cause harm as well. It's not like no matter how many painkillers or how many paracetamols I take, I will just keep getting better and better. No, there's a dose that is given to you. If you take higher dose than them, it will only and only harm you, right? It will only just harm you, isn't it? Next is a therapeutic effect. So another thing is, drugs can either be a medicine or they can cause a therapeutic effect, which is desirable or beneficial drug effect, like treatment of symptoms or the cure of disease on a living body. Such use of chemicals of therapeutic effect is called a chemotherapy. I'm sure you must have heard of it in cancer treatments. So these are some therapies, some chemotherapies are given to the patients. Those are called therapeutic drugs. Okay? But they can even be poisons as well. Poisons are what? Whenever it has more harmful effects. Okay? Then those drugs are called poisons, right? Next is classification of drugs. So again, drugs are classified into various kinds of, on various bases. First basis of classification is pharmacological effect. Pharmacological means what? That it is based on the drug action. Okay? On the basis of what kind of action that drug is causing. For example, this effect is used by the specialist to prescribe a drug, right? For example, if I'm sick, then I will get some antipyretic drug. If I have some bacterial infection, then I will get some antibiotic. So it is based on the action that is that is wanted inside my body, है ना? If I'm unable to fall asleep, then I will get some sleep medicine, right? So on the basis of the action of drug, ठीक है? So for example, analgesic skill pen, है ना? Painkillers in medical term is called analgesic drug. So analgesic kill pain, while antiseptics kill or arrest microorganisms. So there's a very crucial difference between antiseptic and antibiotic, right? Antibiotic is something which you consume, right? Antiseptic is something which you apply on your body, right? Understood? There's differences between antiseptic, antibacterial, and also disinfectants which you use. Disinfectants are used where, bacha? To clean your house, to clean the utensils. These are called disinfectants. So these are various differences between them. So therefore there's differences in their compositions as well, isn't it? Next is drug action. Drug action means what? For example, they release a specific compound in the body or a biochemical process under consideration can be treated by various ways by a single category of drug. What does this mean? That there's one category of drug, but it is responsible to cause so many actions around it. For example, antihistamine. Antihistamine is used for inhibit the action of the compound histamine which causes inflammation in the body. Thus, various ways exist to block the action of antihistamines. What does this mean, ma'am? What is the difference between the two things you just told me? So, bacha, the first pharmacological effect, what did I tell you? For example, if I have pain in my body, I will take a painkiller and the pain will relieve. है ना? So, I know what did I take. Or for example, if I have some infection, I will take an antibiotic. Understood? But for example, if there is a compound called as histamine, which is actually famous for histamine, which is produced in your body for inflammation. Now you took another drug which is called anti-inflammation, antihistamine, है ना? So this antihistamine is what it is doing, bacha. So antihistamine can be anything. It can be any compound that can act as an antihistamine. It is not one kind of drug. It is several kind of drugs that can act as antihistamines. This can act as antihistamine. That can also act as antihistamine. So any drug that is reducing the inflammation is called antihistamine. So it's a variety of drugs, while the pharmacological effect is just one kind of drug, one specific kind of drug. Understood? Next is on the basis of molecular targets. Molecular, what kind of target the drug has. Okay? So drugs are very specific in action. They have to be and have the targets decided. Okay? For example, which kind of biomolecule is the target. They only target the biomolecules. Is the target a carbohydrate? When the target would be the carbohydrate, for example, when you take insulin, isn't it? Insulins, people who are diabetic, the target is mostly protein, yes, but still some medicines can have a carbohydrate target. Or is the target a lipid or a protein or a nucleic acid? Most of the time, it is a protein. Okay? Common structural features show same mechanism of action. So whatever target is there, based on that, the drug will be decided. Next is the chemical structure. So on the basis of chemical structure, they are also classified. For example, if they have a sulfonate group just like this, sulfonamide group just like these, they come under one category of drugs. For example, if they are these are sulfonamides, they can be either, for example, aspirants is another category of drugs, right? So depending upon the functional group that they have, they are classified into as well. Okay, understood? Next is bacha, therapeutic actions of different classes of drugs. Very, very important chart. Please understand this. Everything is just in this chart. You don't have to look anywhere else. For example, what are antacids? Different kind of drugs. Antacids is, for example, when you have too much of acid built up in your stomach. For example, whenever you are feeling very, very hungry, right? So what happens? And you're not getting any food, but you can smell some food somewhere, or you can just imagine some food in your head. And what is happening? Your body starts preparing acid in your stomach already. Your body is very quick with producing acid so that it can digest the food when it is eating that. So what happens? If you are not giving food to your body, after that acid is produced, it's going to cause acidity in your body. That's why we say when you wake up, you should always have breakfast, you should always have proper lunch and proper time. Why? So that you can reduce this acidity formation in your body. But when this acid is formed in your tummy, then what you can take to relieve from it, you take antacids. Okay, they neutralize the gastric juices. For example, eno-gelucil. And the others are antihistamine. Another kind is antihistamine that I just described. Histamine is any compound that is causing inflammation. Inflammation can be outside. Inflammation means what? That there is some bump on your skin, right? Inflammations on your skin. It's very popular right now because everybody is so much into skincare, right? So you get these bumps on your skin. So antihistamines are used to diminish or abolish the effects of histamine. Okay? Examples are they also prevent allergic reactions. So sometimes you develop allergies through various reasons, through pollen grains in the atmosphere. Any reason can be there. Nowadays, allergies are so common. People have it so frequently, isn't it? Okay? Next is, for example, these are terfenadine. These kind of drugs are antihistamine drugs. Next is NAD. NAD are neurologically active drugs. Okay? These are neurologically active drugs, which means they are actually affecting your nervous system. So these are very, very, what do I say, powerful, or the drugs I want to stay away from, right? I am very scared of these drugs because the message transfer mechanism from nerve to receptor, most of the time, neurological disorders, whether you have some depression or whether some nerve was hit due to some accident, right? Then you take these neurologically active drugs. Next is tranquilizers. Tranquilizers are what, bacha? The anesthesia that you get, right, when you're going through some operation. What you are getting, you want to be unconscious for the operation so that you do not hurt while they're stitching on you, है ना? So you are given tranquilizers. But tranquilizers, those are extreme tranquilizers. They can be mild tranquilizers. For example, when people are not able to fall asleep, then they're given mild form of tranquilizers which will make you fall asleep, right? So these are also used in the treatment of stress, mild or severe mental diseases again, है ना? Because it is making you do what? So whenever people are stressed or they have mental diseases, what is happening? Their brain is too much active, isn't it? That's why they're taking too much stress. They're unable to sleep. So it is causing harm to their body, है ना? So that's why they're also given these sleep medications so that they can just sleep. It is not causing any effect on their stress. The stress level is not reducing, but the medicine is helping them rest. So in return, what is happening? They are becoming healthier. Okay. Next is anti-fertility drugs. Anti-fertility means what? The conception drugs. Okay. For example, conception of fertility, example, norethindrone. Okay, I'm very bad at these things called norethindrone. Norethindrone is a kind of anti-fertility drug when you do not want to conceive. Next is antimicrobials. Antimicrobials which what? Will destroy the microbes. Very simple. Okay, they destroy or either prevent the microbes development or inhibit pathogenic action. These are once again of three kinds. Number first is antiseptic, as I told you. Antiseptics is used what? It is used in the body. For example, the Dettol that you use. Whenever you fall down, right, and you have a scratch, right, and a little bit of blood is coming out, what your mother does, she actually applies Savlon or Dettol. Why? Because it's an antiseptic. Because when you like hit and the blood is in direct contact with the microbes in the soil or on the ground, then what can happen? It can cause infection later on. So to prevent the infection, application of Dettol antiseptic is very, very essential so that those microbes do not develop infection on your body. Okay, next is antibiotic. Antibiotic is what? It will kill or prevent the growth of microorganisms inside your body, right? So the very best example is sometimes you will see pets around you. See, antimicrobial infection to understand in human cases a little bit difficult, right? Because we do not have those microbial infections that common. But you can consider the For example, if you have dog or pets in your home, then you will understand the microbial infection on them very much better. Sometimes they develop pus on their feet, right? Or if some other animal bit them, then they also develop pus once again. To heal them, to heal the microbial infection, they're also given antimicrobial injections as well as tablets to take in, so that those microbes do not grow inside the body. Okay? So antiseptics is used for the outside treatment. Antimicrobial treatment is, antibiotic treatment is given for the inside treatment of, inside prevention of microbes. Okay? Then is your disinfectants. Disinfectants are used for the materials, your floor. So whenever you drop phenol and whenever pocha is happening in your house, right? So what is you're doing? You're killing the microbes. So those are disinfectants which you are using to clean your floors or your utensils or the surgical instruments. Those are disinfectants. Okay? And they have and they cannot be applied on living tissues. Once again, very, very important. You cannot apply phenol on yourself. No, never. It's toxic. Okay? Example is iodoform. Okay? Next is on the basis of mode of control of action of microbial diseases. Once again, it can either be bactericidal or bacteriostatic, which means what? Bactericidal means what? They will kill the organism in your body. They kill bacteria in your body. Bacteriostatic means it stops the growth. Kills means it is killing. It is fighting and murdering them. And in static means it is stopping them, inhibiting them. There's a difference between the two. Right? Example is penicillin kills, aminoglycosides kills, ofloxacin kills. But erythromycin stops, tetracycline stops, and chloramphenicol stops. And what is the difference between the two? I will let you know. For example, there are so many gut bacteria in your stomach. Hai na? Sometimes those gut bacteria increase in number and or some foreign gut bacteria is introduced. So what do you want to do? Do you want to give a bactericidal which will just kill all the drug bacteria, or you want to give bacteriostatic which will stop the growth of more bacteria? We want to stop the growth, right? We don't want to kill all the healthy bacteria as well. Killing bacteria is even more, the healthy bacteria is even more harmful for our body. So that's why we give bacteriostatic in that case. But when very bactericidals, where we want to kill the bacteria. Understood? Next is on the basis of spectrum of action. Brand spectrum of action. Sorry, this is not brand. This is actually broad. This is actually broad spectrum of action, narrow spectrum of action, limited spectrum of action of antibiotics, which means what? It has a broad or a limited or a narrow. Okay? So antibiotics which kill or inhibit a wide range of gram-positive and gram-negative bacteria. Broad means what? It is killing both gram-positive as well as gram-negative bacteria. Example, ampicillin and amoxicillin. Isn't it? Isn't it, bacha? Okay? Next is narrow spectrum of antibiotics. Antibiotics which are effective mainly against gram-positive or gram-negative bacteria. So what is happening with broad? It is killing both gram-positive and gram-negative bacteria. There are only two kinds of bacteria, positive and negative. Gram is the name of a scientist on which the positive and negative bacteria are. And what are those? What are the structure? You don't have to go through that. Those are the things for biology people. We just need to know that two kinds of bacteria, gram-positive, gram-negative. It is a stain through which we identify positive and negative. Okay? Next is which kills both is a broad spectrum. Narrow is which kill either the positive or the negative. It is a narrow spectrum, and these are the examples of both. Limited means what? The antibiotic effective against a single organism or diseases. A single organism, right? So these are the differences between these three. Next is mechanism of drug action. Very easy. You've been studying this, I don't know, since 8th, 9th standard. So how does drug actually impact you? For example, the drugs affect mainly the proteins. I told you, drugs will attach to the macromolecule in your body. Major macromolecule that drugs attaches to are the proteins in your body. And the proteins in your body that acts like a site of attachment are mainly called your what? Enzymes. What are they called? Enzymes are another kind of proteins only. but they are very, very specific. That's why they are called enzymes. Okay? So what is happening? For example, the enzyme has an active site. Active site means what? That it has this site where there's a dip inside of it. Okay? And there's a substrate. So this mechanism is also called the lock-in key mechanism. For example, this acts as a lock, and there's a key which goes inside the locks. And for example, a lock can have just one key, isn't it? It can be opened by just one key. Similarly, the enzyme can be attached by only specific kind of substrate. And then what you're getting over here, you're getting an enzyme substrate complex. Okay? So this is how the drug actually operates in your body. Next is what, bacha? Mechanism of drug action. So you understood what is happening. The enzymes in your body, the drug gets logged into it, and then it causes a biological response in your body. Now, how is it doing that? There are two kinds of mechanism. One is the competitive inhibition, which means what? That the enzyme in your body, if it is there, which means another kind of substrate which is also prepared by your body, will get attached to that enzyme. But what this drug is doing, this drug is actually imitating. It is trying to imitate the substrate, right? This drug is trying, this is the natural substrate produced in your body. But the drug is imitating the substrate and then attaching to the enzyme. Okay? Then what is happening? What is happening? This drug is actually inhibiting the attachment of this substrate, right? And therefore, it is curing you using this mechanism. It is inhibiting, it is not allowing the natural substrate to attach to the enzyme in your body because it is attaching itself, and therefore it is called competitive inhibition because it is competing against the substrate in your body. This is the first kind of drug mechanism. The second kind is called non-competitive inhibition, which is doing what? For example, this is the enzyme you have. In the enzyme, this is the active site, right? It also has a site called as allosteric site. Somewhere other than the active site, there's another site, and on this site, your drug gets attached, which is called the inhibitor. So your drug is now attaching on this site, and when the drug attaches on this site, what is happening? Your enzyme is changing its shape. So because this shape is changed now, what is happening? The substrate cannot recognize. Now substrate cannot add over here, isn't it? So again, what it is doing? It is actually inhibiting once again. But this is called the non-competitive inhibition. It is not competing with the substrate. It has altered the shape of the enzyme so that the substrate doesn't recognize it again. So two kinds of drug action understood. Everybody understood this? Okay? Next is this. Examples, very, very important. I've attached all the examples over here. The examples of antacids, very important. Please go through the molecular structures. I'm again telling you these molecular structures are very, very important. For the antacids, histamine has this structure. Ranitidine, again an antacid, has this structure. Okay? Next is your antihistamine, which is used for reducing inflammation in your body. The examples are brompheniramine. This is the structure. Next is terfenadine, or your dimetap, or your dimetane, or your seldane. This is the structure. Okay. Next is tranquilizers. Tranquilizers are again of various types. I told you sedative means what? Which causes sleep in your body. Next is mood elevators or antidepressants, which means whenever you are depressed, right, and you want your mood to be elevated, people who are depressed are prescribed once again tranquilizers, which are mood elevators. Okay? The examples are like this: Equinil, your chlordiazepoxide, and meprobamate. These are the molecule structures as well. Once again, very important. Whatever structures are given in your NCERT are the important structures, right? Next is analgesics, which are analgesics means what? Which prevent you from fever, right? For example, morphine, codeine, and heroin. These are actually narcotics. Narcotics means what? That these are actually drugs which are causing more harm and no good. Okay? So these are analgesics like this. Next analgesics are ibuprofen and aspirin. So actually analgesics mainly are not to reduce fever actually. Analgesics are mostly to reduce pain in your body, right? So whenever you have very much, who are into drugs, people who are depressed, who are like not going straight in their life, right, who have so many mental problems with them so that they cannot come out of it, and what do they resort to? They resort to all these kind of drugs because it is doing what is killing the pain inside the body, if they have no pain. But right now there are some treatments even where morphine is given. Morphine is given to what? Also morphine is given for physical pain as well, right? For example, when you go through a major surgery in your body, then patients are like in hospitals, they are given drips of morphine because it helps to kill the pain inside your body. But those are medical uses. They are given in good doses or useful doses which are not harmful to your body. But people actually make harm, like do drugs, right, and cause harm to their body using these narcotics. So narcotics are different, that there even small amount of them, right, if they are not medically prescribed, even small amount of them will cause harmful effects to your brain, right? Next is this non-narcotic example, ibuprofen and aspirin, which is very common drug prescribed by doctors as well. Next is antibiotics. Antibiotics are used for the killing the bacteria inside the body, right? Penicillin and chloramphenicol, very important structures. Please do not miss out on these structures. Next is antiseptics. Antiseptics is anything which I apply on my body, right? So to kill the bacteria. These are the very important antiseptics, chloroxynol, terpenol, the structures. And for example, Dettol. What is a Dettol? Once again, it is a mixture of chloroxylenol and terpenol. It is a dilute solution of them to clean wounds. Then is bithionol. It is added to soap to impart antiseptic properties. Very important. Next is tincture of iodine. What is tincture of iodine? Asked several times in your exam. It is a 2 to 3% solution of iodine in alcohol, which is a powerful antiseptic for wounds. Iodoform is also used as an antiseptic for wounds, right? To apply from the outside. Next is anti-fertility drugs, which are used to prevent conception. So for example, norethindrone or Novarestol, right? Next is, we have completed the drug section. Next section in your notebook is the artificial sweetener section. Again, very important. So these are very artificial, means these are prepared in laboratories. These are the kind of sweetening agents. For example, aspartame, very popular. If not in India, it is getting popular in India as well as of now. But outside India, it is used so much because its sweetness value compared to the normal cane sugar. Sugar cane is actually 100% more sweet, right? And saccharin is 550 times more sweet. Sucralose is 600 times more sweet. And altrame is 2000 times more sweet than the natural cane sugar. So these are the artificial sweeteners you should know with their structures over here. Last is soaps and detergents. Very easy topic. You've been studying about soaps and detergents, I don't know, since your 8th standard, 7th standard, 9th standard, 10th standard. Once again, soaps are there, right? So this is very important advanced topic. I'm not going to say do not read it, but I know most of you are aware about the differences between soaps and detergents, right? Soaps are what? Soaps are sodium or potassium salts of long chain fatty acids, which look like this. Everybody's aware of that. These are soaps. These are long chain of sodium potassium salts of fatty acids, isn't it? Next is detergents. Detergents are what? Detergents can be anionic or cationic or even non-charged detergents. What is the difference between soap and detergents? You know, ki ma'am, soap do not lather well in hard water while detergents do. So this is the major property, and also their constituency is different. Okay, detergents are used to wash clothes and soap is used to wash body. So this is more harsh. Soaps are more softer side, right? So for example, L'Oreal, what are anionic detergents? Anionic detergents have this kind of sodium do-decylbenzene sulfonate as these are the most famous example. How will you actually identify anionic detergents? That they have this kind of sulfonate groups, right? These are anionic detergents. Next is the cationic detergents. They will have a cationic part like this, right? These are cationic detergents. And also, just to give you a little bit brief idea, that cationic detergents are actually expensive than anionic detergents, and that's why we mostly use the anionic detergents in everyday life. And then there's the non-ionic detergents, which are made of stearic acid and polyethylene glycol. They do not have any ions in them. Can you see? Because it is made up of acid and alcohol, which means a ester group is formed. Can everybody see? Ester group is formed. And because, can you see the H is there? That means they are going to form H bonding, isn't it? So these are non-ionic detergents. I think this is all I had. Yes, last is the kind of biodegradable as well as non-biodegradable detergents. So biodegradable detergents are those which have straight chain hydrocarbons, but non-biodegradable have branch chains. Okay? Biodegradable, obviously, which can be easily decomposed by microorganisms. Non-biodegradable are, these are easily decomposed by, cannot be easily decomposed. Example is sodium lauryl sulfate. This is a very good example of biodegradable detergents. Understood? So I think this was the last topic. Yes, we have completed both the sections which are from the organic part, which will definitely come in your JEE Advanced exam, but was not in the JEE Mains section. Polymers as well as environmental chemistry for the organic section. Tomorrow, Nabamita ma'am will take your physical, and then later on she will take the inorganic section, which was not included in the JEE Mains exam. Once again, if you have any doubts, any questions related to especially organic chemistry, you can reach out to me on my Telegram channel, isn't it? My Telegram channel, which is Nandini JEE, right? Ask me any questions till your exams are over. Please make use of this. Thank you so much for attending the session. Any questions, ask me now. Otherwise, I'm going to end the session. Otherwise, I'm going to end it. I am going, ma'am, please do something for cheating. I wish I could have done that for myself as well, so that cheating, bacha, why do you want to cheat in exam? It's so wrong. It's so wrong. Even if you cheat in one exam, okay, remember one thing. Even if you cheat and clear JEE, what will happen? When you go to IIT and then you have to secure a good, why do you want to go into IIT? So that you can get into your favorite company like Google, Facebook, Microsoft, Apple, Tesla, whatever big companies are there which pay you well, which makes you roam around the world, which gives you the opportunity to work from anywhere in the world, right? Because we have now gone global. These companies are hiring globally. But what is the use of cheating, right? Because when they ask you a question in their interviews, you're not going to clear that then. There's no point of cheating in any exam, because as you grow up, the life is only and only going to depend on how much you know here. That is it. That is the truth of life, right? Okay? Yeah, you cannot get that bag without actually studying, but I'm already telling you this. If you do not study, IITs is going to be terrible for you. So many people leave IITs. Why? After first year, so many people are leaving IITs. Why are they doing that? Because they cannot cope up with the pressure of IITs, with the syllabus of IIT, with the test structure of IITs, because it is again a very tough scenario. But toughness is what makes you a strong warrior as well. Toughness is what gets you going for those companies, for those opportunities. These opportunities, when I talk about them on just a camera to you guys, it seems like, and when you're listening to them in your bed or on your phone, wherever, you feel, wow, I'm going to travel the world, I'm going to do this, I'm going to do that. But once those opportunity actually comes to you, you're going to get a little bit scared. Why? Because you have to do everything on your own. Adulting on your own is not an easy task. But IITs help you make it easy, because it's going to pay you to do adulting. It's going to be really, really good for you guys. Okay? How to do organic for advanced? This. Connect with me on here. Whatever doubts you have, whatever reactions you have, ki ma'am, I cannot understand this reaction, how to approach it. I'm not able to form the products in this, how to approach it, how to do this. Ask me here. See, in this, no matter how many sessions I take, no matter what I do, until you do questions on your own for organic. Organic is once again just like a physical chemistry. Do not take it lightly. Till you pick up your pen and paper and draw the reactions. Draw the arrows. Ki, okay, this is the negative charge. It will attack the positive charge. Then this will happen. Then it will be super easy. But you have to pick up the pen and the paper for that. You have to practice, 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 practice. Because without practice in your JEE Advanced, what happens? Because there's so many reactions, everything gets mixed up in your head. And you know, whenever I look at the JEE Advanced paper, there are so many questions which like 70% of the students got wrong. There are questions with 85% of students got incorrect in the JEE Advanced exam. There are so many questions. You can take out the data. And when you go look at the question, okay, how difficult was that question that 85% of students couldn't attempt in the JEE Advanced paper. Then when you look at those questions, they're super easy questions. Means they are just single step questions, not even a double step question. I just look at these questions. This is the COH group. These are the groups attached. In the next step, I can form the product, right? Why do you get confused? Why 85% of students are not able to answer that? Because they have not practiced with a paper and pen. They have not given enough time to the organic chemistry as much as they've given to the physical or to the math section or to the physics section. This organic requires your commitment, your time, your efforts. Very, very important. Okay? This is my only final advice. Do as many questions as you can. I'm once again telling you, there is a rank accelerator JEE Advanced book of Vedantu. Right now, go and buy that. It has beautiful questions. Even if you go through those questions, in organic chemistry especially, because I've gone through the book, it is beautiful, and so many times the question type is repeated in your JEE. I'm not kidding. Literally the question type is repeated. We keep on seeing these, all the teachers keep on saying this is how beautiful these books are, and if the students are able to take advantage of that, it would be great for you guys. Go and buy the book. The link is in the description box below. JEE Accelerator. And if you have any doubt in any question, right, ask me. Why am I here? I'm telling you once again, ask me here. I'm here to help you guys out. Please, this is the last chance for you guys. Take ample advantage of it. Ample, okay? I will meet you again next time. Okay? Chalo. Thank you so much for attending. This is my last piece of advice for you guys. I got into too much of advice mode today. Chalo. Bye. Thank you.